Hello guys, welcome back to KD Code. In this video, we are going to see one more interesting project, which is diamond price prediction. For this project, I am using dataset which has 10 attributes along with our target attribute price. So these are the remaining 9 attributes: caret, cut, color, clarity, depth, table, x, y, z. Let's see about them one by one. The first independent variable or attribute is caret, which ranges from 0.2 to 5.01, and it is really the physical weight of the diamond, guys. So it is measured in metric carats, and each carat is equal to 0.2 grams, guys. You can refer these images here to compare the diamonds of different carat. So obviously the diamond with larger carat is big in size, right? And second attribute is cut, which is the shape of the diamond. It will be more attracting to our eyes if it has more accurate and precise cut. If you see this image, let me zoom it. If you see this image, here it is mentioned 5 types of cuts, and if you observe this one, it has clear and accurate cut compared to all other diamonds. So it comes under excellent category cut, guys. And same goes for other categories also. Based on their cut, precise and accuracy, they will go under different categories, right? And the third attribute is about color. So it is straightforward, guys. Diamond colors are in range of light yellow to colorless, and the colorless diamonds are very rarest among all the diamonds, guys. So if you see this image, let me zoom in again. So if you see this image, D, E, F are colorless diamonds categories, and G, H are under near to colorless categories. And if the diamond is slightly colored, based on the transparency of the color, it goes to different categories as mentioned here. Like I, J, K to M is one category again, and N to R is very light yellow category. This is another category. If your diamond has different colors like blue, pink, red, etc., they all comes under fancy category, guys. Okay, it's about the color attribute. Let's see another attribute now. And the next attribute is clarity. This is the fourth attribute, and there are internal and external categories for the diamond, which are called inclusions and blemishes correspondingly. And diamonds are very rare to occur without these inclusions or blemishes. And these characters in this image can be seen through magnification. You observe here, we always prefer the clean and clear diamonds like these, right, guys? So the clarity attributes is very simple, guys. If the diamond is crystal clear, it comes under flawless and internal flawless categories, right? And there are other categories also, like very slightly included, very slightly included, slightly included, and included. So included, if you see, it has more unclear transparency. So we are unlikely to buy these diamonds, guys. So if the diamond is very clean and clear, we will buy those diamonds, right? Obviously. So that's it for this clarity attribute, guys. Let's see the next attribute. And the fifth, sixth, seventh attributes are X, Y, Z, where X is the length of the diamond, and Y is the width of the diamond, and Z is the depth of the diamond. And the images here illustrates the same, guys. Let's see the next attributes. The table of the diamond, it is defined as the width of the top of the diamond. It reflects the light to all directions, which makes the diamond shine and attractive. So that's why table attribute is also very important. So let's see about other attribute, guys. The depth percentage of the diamond. The depth and depth percentage of diamond are not same. Depth percentage can be derived from X, Y, Z using the formula Z divided by mean of X, Y, which is equal to 2 into Z divided by X plus Y. And it can also be defined as the height of the diamond measured from bottom tip to the table, right, guys? If you observe these images here, the diamond with good depth percentage has a perfect shape, right? And it seems quite attractive than other two diamonds here, right, guys? Let's see about the last variable or attribute, the price of the diamond. This is very interesting variable, and I hope no one needs explanation for this. Just kidding, guys. Price variable is the one we are going to predict in this video, and it will be in US dollars. So I hope everyone understood the data attributes I'm considering for the input for our model, right? Without any further delay, let's do it, guys. So you see here the CSV file, diamonds.csv. This is the dataset I'm talking about, right? So if you see here, the carat, cut, color, clarity, depth, table, price, X, Y, Z, all these variables we took here. There are almost 50k rows here. So our dataset has 50k rows. Let's create a new notebook here, guys. Let me rename it. Yeah, so here we are again with a new notebook, and as we seen in the introduction of this video, this time we are going to predict the price of the diamond based on the attributes we discussed earlier. We will use the pandas library to read the dataset and perform data manipulations, right? So let's import it. Import pandas as pd. Also data equal to, I'll read the CSV file now. Read underscore CSV diamonds.csv, right? And data.head. So you see, we got our data set here, but there is one row which is not necessary here, right, guys? So I'm going to remove this. We can use data.drop function to drop any column, right, guys? So like this, comma access equal to 1, and we have to store it in the data variable again, data dot head. Let's see. So you see this column got dropped and we got our data here. Now let's see the shape of this data set, right? So we can use data dot shape. So you see 53,940 rows and 10 columns, right guys? Now let's see the data types of the columns in this data set. We can get the data types of the columns using the dtypes attribute of the data frame, or simply using info function. So we can use info function, data dot info, like this. So you see we got all the data types of all the attributes here. So from this output we can see the data set has 6 float columns. They are caret, depth, table, xyz, right? And 3 object columns also, cut, color, clarity, right? And there is only one integer column, that is a price column, which is our target column, right? Now let's see if there are any missing values in the dataset. We can check for any null or any values in the dataset using isNull function or isNA function. So let's run it. Data dot isNull, which gives us true or false for each of the value, whether it is null value or not. So everything seems false here, but not yet confirmed. We have to use dot sum to sum up the null values and give a count to each of the column. So you see there are no null values here. Let me do it for NA values also. So isNA will find us the non-available values in the dataset if there are any. So after running it, I got 0. So there are no null values or non-available values here in this dataset. Now let's check if there are any duplicate rows in the dataset. We can check for duplicate rows using duplicated function like this. Data dot duplicated, right? And we can list all the rows which are duplicated by taking only true values, right? Here there are false. We just see false, but there might be some true values where duplicated rows are present. So let's take only the true values now. We can take true values like this. Data duplicated equal to true, like this. Capital T. Let's run it. So you see there are 146 rows of duplicated values, right? We have to drop these duplicate values because we don't need the duplicate values to be trained in our model. So let's drop the duplicate rows from this dataset. We can use simple drop duplicates function to drop all the duplicates from this dataset. So data dot drop duplicates, and we will assign it to data again. Data dot shape. Let me print the shape also after dropping the duplicates, right? So if you see here 53,794, but previously it was 53,940. Now let's see the summary statistics of the dataset. We can get the summary statistics of the dataset using describe function like this, right? Data dot describe. So this table shows us the statistical summary of the dataset, like count, mean, standard deviation, minimum and maximum values, and also the quartiles of the dataset. If you observe X, Y, Z columns, the minimum value is 0 here, which is not possible for the dimensions of the diamond. So the rows with 0 values in X, Y, Z columns are invalid or NA values. So we can replace 0 with the median of the respective columns, right guys? We can use the replace function to replace the 0 values with the median of the respective columns. Let's do it. Data of X, data X. You have to assign it after replacing, right? So we are doing it. Dot replace function. We have to replace 0 with the median of that column, right? So we have to find the dot median here like this, and that's it. So we are replacing all the 0 values in X column with the median value of the same X column, right? We can do the same thing for Y and Z also. Simply copy paste and change the variable name. Oh, I got median. Spelling wrong. Now let's run it. Now let's see the describe again. You see the minimum values are not 0 now. So they are replaced with the corresponding median values, right? So we checked out the null values, duplicate rows, and invalid values in the dataset. Now let's move on to the next step, which is to visualize the data. For numeric columns, I will plot a histogram, and for categorical columns, I will plot a count plot, right? Let me import matplotlib and cbon for the plots, like this, right? I will define a function here. Let's say plot data, which takes column data and column name and also its type, right? Data type. Because based on the data type, I have to plot the graph. That's why I'm using it. So at first, let's set the title to our plot, right? plt dot title distribution of, I can give the column name here. I'm using f string here, and let me give some font size as 12. Okay. And then, as I said, based on the data type, I will plot histogram for numerical columns and count plot for categorical columns. So to implement this, first we need to check the type of the data, right? So as we are already getting it from here, data type, let's use it in the if condition, right? If data type is equal to float, then I will plot an hist plot from c1 dot hist plot. We have to give the column data, we are giving the get data, and we have to set the bins as 50. So our plot will take 50 rows and group them to draw the plot, and also KDE as true to draw a smooth curve on the bars for better representation. Let's also give some color values as .cm, right? And we have to just plot the graph and show it. Plot dot show, right? Else if the data type is object, then it is a categorical value, right? So then we need to plot count plot, which takes the whole data and also the column name. So data equal to data, it takes the whole data, and the column name you have to send it as x, the column name, right? And we can set the colors also here. Palette equal to yellow, green, and blue, like this, right? And then show the plot. So I have defined this function now. Let me call it using a for loop for each of the column, right? So for I in range of data.columns, so for each column I'm calling this plot data function to plot each of the graph for the float values, that is the numerical values, and also for categorical values. I'm drawing two different plots. Let's see. So you see the distribution of caret, which is in numerical values data, we got this histogram, and also for distribution of cut, which is a categorical data, we got this count plot, where we got the count for each of the categories. Like ideal, it has more than 20,000 rows, and for premium, it has more than 10,000 rows. Like that, we got a count for every distribution, right? For distribution of color, we got same thing, E, I, J, H, F, G, D, as we see in these categories earlier. And also for clarity, we got all these counts. And for distribution of depth, this is the numerical values. So you see, this is the graph. And for distribution of table also, we got the graph, and also the X, Y, Z, everything here. By analyzing all these plots, we get some insights about the dataset. Like, let me write some insights here. So for the cut, if you see, cut, here, the most diamonds are in ideal, premium, and very good, right? These categories. So we can write the most diamonds are in the ideal and premium and very good cut categories, right? And for the color, let's see. For the color, we find G, H, and also E and F, right? So G, H, E, F, we got all these four as more frequently occurring colors, right? So we can write it as color. A higher frequency of diamonds is observed in G, H, and E, F colors, right? And also we can check for clarity. Diamonds are mostly in SI1 and VS2 categories, right? So if you see SI1, it has more than 12,000, and VS2, it has nearly 12,000, right? These two are most occurring categories in the diamonds, right? So let's write it, clarity. So we got some insights from these graphs. So let me quickly draw a scatter plot for caret versus price. So let me copy paste some code here to buy some time. So first I'm setting the figure size as 10 cross 6, and I'm using C1 again and using scatter plot function, x value as caret and y value as price, and sending the whole data, and I'm setting the color as green here, and setting the title as caret weight versus price, right? And x label as caret and y label as price again, build as true, and showing the plot. That's it. Let's see it. So if you see it from the plot, we see the prices of the diamond increases along with the caret weight, right? Let me draw a pair plot with all the attributes including price, so we can compare the price with all other numerical data, right? We can use C1 dot pair plot of data like this. It will take some time. So my insights I have written here, caret increases, price will also increase, right? So this is the pair plot for all the features along with price. This will give us the relationship between all the features on the target variable, right? For example, we seen earlier caret weight is directly proportional to the price of the diamond, and if you see here the price and caret here, or the price here and caret here, this graph is the same graph as we drawn here, right? So it shows the same thing. As it is, we can see when x value increases, the price also increasing here, right? So we're able to find there is some linear relationship between these variables and the price value, right? And there is one thing we need to handle it here. We need to normalize the skewed data here. So the skewed data is nothing but it is not distributed normally throughout the data set. So the data will be skewed towards one side of the values, right? So here we can use dot skew method to find the skew values for all the attributes. If it is greater than 0.6 and less than minus 0.6, we have to normalize. Let me use this skew function on caret data of caret like this dot skew, right? So if you see it is 1.11, so it is greater than 0.6, right? So we have to normalize this. So how can we normalize this? We have to normalize these values using a logarithmic function from numpy, right? So I'll be using np dot log1p function. So why this function? There are many log functions in numpy. Why we are using only this function? So if you see the caret values here, data caret, all these values are in between 0 to 1 mostly, right? So for these small values, it adds 1 to the x values and converts them to the corresponding log values. So this is to be done to avoid the loss of precision in x values which are close to 0, right? So we don't lose any precision for these values if we use log1p, because it adds 1 to the x values and convert them to the corresponding log values, logarithmic values, right? Let me do it quickly. So like this. NP was not defined, okay. So I'm importing numpy as np. So if you see now the caret values, if you find the skew value for these caret values now, it will be less than 0.6 or near to it, right? So let's see. So it's 0.57. So now it is pretty much normalized, I can say, or the stable values, right? So not only for caret, we can also find it for other numerical values like depth, table, price, x, y, z, everything. So let me run a for loop to find the skew values which are greater than 0.6 or less than minus 0.6, right? So I'm running a for loop on top of all the columns and then checking the data type for the columns. If it is float, and if the skew value for that column is greater than 0.6 or less than minus 0.6, I'm printing that skew value along with that column name, right? So if you see here, the table y, z, we got these three columns with uncertain skew values, right? So we need to apply logarithmic function to normalize the skewed data, which is table y, z, right? But here I will apply this normalization for only table, but not for y and z, because I will create a new attribute called volume using x, y, z, right? This x, y, z, because volume is nothing but length into breadth into height, right? So I'm calculating the volume of the diamond instead of considering these x, y, z separately, right? Make sense? So this is called feature engineering, creating new columns, new features out of the existing attributes, right? So I'm using the formula here. I have to just multiply all the length, breadth, and height, right? Now if you see the data set, we got the volume. But you can ask me, does the volume data get skewed? Can we find the skew and apply the logarithmic function in the same way we applied it for caret? And also we have to apply it for table, right? Yeah, we can do the same thing here. So let's find the skew value for volume, right? Dot skew. So if you see, it is 3, which is greater than 0.6. So let's normalize this. So copy this. I'm going to convert volume and also the table here, right? So let's see the data here again. So if you see, volume got changed, right? Instead of xyz, we are using volume. So we can drop xyz, right? So let me drop them. Data dot drop. Then they are no longer required for our training. Let me store it in the same variable. data dot head. I have to use axis equal to 1, right? So if you see here, I have dropped x, y, z here. Instead of them, I'm using volume, right? So it's time for normalizing all the numerical values again for faster computation for our training the model, right? So for that, we have to use the standard scalar from sklearn, right? Let me import it from sklearn.preprocessing. I imported standard scalar here, and we have to create an object for this standard scalar, right? I'm creating the object, and now we have to fit transform the data, which are the numerical data, obviously, and we have to scale them in order to make the processing faster, right? So I'm editing over all the data columns, and I'm checking the data type here now. Dot d type, if it is equal to float values, right? I'm going to create a new variable, let's say scaled, the variable name and scaled, where I have to store the transformed values, right? Scalar dot fit transform of data. So this is how you do it. And data dot head. Let's see. So if you see, we got caret, depth, table, volume. All this numerical data got scaled. And there is one variable which is price, which is our target variable. So we are not doing any scaling activities on them. So until now we have seen we are pre-processing the numerical values, and we did a good job of removing the duplicate values, removing the null values, replacing zeros with median, and also scaling it, stabilizing it. We did all the possible pre-processing techniques to make the numerical values ready for our training, right? So it's time for pre-process our categorical values now, right? So what are our categorical values here? You see the cut, color, clarity. These three are our categorical values, right? So as the model cannot pre-process the string values, it only processes the numerical values. So we have to convert these categorical values to the encoded form, right? So I'm going to use the popular ordinal encoder from sklearn again, right? So let me import it, ordinal encoder. So again, we have to create an object, right? So after creating the object, same thing I have to do it here. Instead of scaling, I have to encode them, right? So I have to replace the scalar with encoder and this float value with object, because we have to do it for categorical values, right? And I remove this scaled and replace it with encoded, right? Let me run it. It is pretty much good. So if you see here, the cut, color, clarity, all these three categorical values converted to numerical values, right? You see 2, 3, 1. So 2 is corresponding to ideal and 3 is corresponding to premium. Like that, every value will be converted to their encoded value. It's just 1, 2, 3 until the unique number of categories that column had, right? So let me take the x and y values for our model, right? So I can take the caret scaled, depth scaled, table scaled, volume scaled, and cut encoded, color encoded, and clarity encoded as my x data, right? All the other data like caret, cut, color, all these data are not required because they are pre-processed and we are storing them in separate variables, right? So I'm using the pre-processed data now, and for the target variable, which is price, I'm storing it in y, right? So this is our x and y data. We have to segregate it like this, and if you want to see it, x dot head, it looks like this with 7 columns, 1, 2, 3, 4, 5, 6, 7, right? And if you see y dot head, it has only one column, right, which is price. Now it's time for dividing our data into training and testing data sets, right? So for that, I'm importing train test split from sklearn, right? And we can use train test split to split our data into training and testing data sets. So I'm using it here. I'm sending x and y here. Also, I mentioned test size as 0.2. So 20% of the data will be our test data, which goes into x test and y test. So this random state can be used. So it will split the data in the same way. It is splitting now if I use the same random state again while running the model, right? So that's why I put this. And let me print the shape of the training and testing data sets. Let's run it. So if you see the training data set and testing data set, all the shapes are mentioned here. So for training, it is 43,035 rows, and for testing, it is 10,759 rows. Pretty much good, right? So what's next? The next step is to train our model. So our training data is ready and testing data is ready. We have to create the model, right? The question is which model to be used, right? There are many models, and I have listed down a few models out of them which can give us the better accuracy for this project, right? So let me import all of them here. So these are the models which I thought would be giving a better accuracy. So I'm importing linear regression, ridge regression, lasso regression, k-nearest neighbor, patient trees, random forest, gradient boosting regressor, ADA boost, XGB regressor, and support vector regressor, right? Right. Along with these models, I'm importing grid search CV and also cross validation score. The reason why I imported this grid search CV here is there might be different models I can make from these all these models, right? So for linear regression, there I can use different values. For example, for random forest regressor, I can use different estimators and depth parameters to make different random forest regressors models, right? But out of them, I have to find the best random forest regressor to fit this data, um, to predict this data, right? So I'm using grid search CV to find that best model out of all these different random forest regressor models. Not only for random forest regressor models, for all of these models, I'm using it to find the best out of them, right? So let's see how I did this. So I created a dictionary here with all the objects of these models, right? Let's run it. Now I have to define all the different possible parameters for all the models, right? So I defined it in a dictionary format in this way. So for ridge regression, the alpha value, these are the different alpha values I can give. And lasso regression, the same thing. And for K-and regressor, these are the nearest neighbor values, 3, 5, 7. You can give whatever values you need, and you can give as many as values as you can, because you want the best model out of them. So we can try out all the possible ways, but it will take a long time. And for SVR, support vector regression, we can use different cardinals like linear or BF and SC values like 1, 10, 15, 20, anything, right? So these are the different parameters I can give for that specific models. I define it here. Now I want to create a function to take all these inputs and train the model based on the inputs we are providing to that function, right? So I created a train model function where it takes the model name, which is the model name here, and the model, and the param grades, this dictionary, and X train and Y train data. In this case, it is same for every model, and I'm using pipeline here and grid search CV and also sending this param grid, and then I'm fitting the X train and Y train here, and after fitting, the grid search will find the best model out of them. So grid search dot best estimator will give me the best model, and I will return that best model, right? Let's run it. Now after training the model, I have to evaluate the model. So I created one more function for evaluating the model where it takes the model after training and X train, Y train, also X test, Y test. So it's going to predict the X train first and then X train, X test next, right? We are going to find the predictions for X train and predictions for X test, and we are going to calculate the score for training data and the testing data after predictions, right? We are going to return the two predictions score, right? The training score and testing score. And then I'll be storing all of these training testing data sets, and then I'll be storing all these scores in a data frame. Let me create a function for that. So save model results. Here I'm taking the model name, model, the best parameters, the best model I can say, and the train and test scores. So I'm creating a dictionary out of it and converting them to a data frame, right? So we can see the data frame every time the model runs, right? Let's run it. Now let me give linear regression first to train the data, right? I'm giving the model name as linear regression and getting the object from models. So as we defined the objects earlier here, I'm getting the object model here and getting the grid parameters from here, which is an empty dictionary here, but for other cases there are many parameters, and training the model here, right? So let's run it. So it took a very less time. I think it got run already. Let me take the training and testing score here by calling evaluate method and sending this best model here, right? We have to import the R2 score. Okay, I imported it. Let me save the model. We have defined the function already. Save model results. So let me call that function. I'm calling that function with the parameters best model, with the best model parameters and training and testing scores. Right? It will store them in some list, results list, and then convert them to the data frame. We can access this result data frame from anywhere in this notebook because it is a global parameter. Right? So let's print it. The linear regression itself, it's giving 88% accuracy for training dataset and 88% the same thing for testing dataset. Okay, but if it is greater than 90, 95, it would be great. Let's train for one more model, that is a ridge regression maybe. So we just have to copy paste all of these and change the model name, right? So let me copy paste. So instead of linear regression, I have to give it as ridge regression, right? Let's run it. So it took very less time again. Let's see the data frame now. So you see the ridge regression is not giving much greater accuracy again. It's similar to linear regression. Let me use the lasso regression then, right? So let's see. Same thing goes for lasso regression here again. So let me use KNN regressor again. So instead of lasso regressor, I'm using KNN regressor, right? So let's see. KNN regressor, it's giving us 97% accuracy, right? So it's pretty much good. It's performing great. Let's see the other models also. Let's take Dataset regressor. Let's run it. So it's giving 98% accuracy, which is better than KNN again. So let's see ADA boost now. Okay. Ignore these warnings. Let it run. So if you see here, ADA boost, it's not great. It's giving 88% accuracy, same as linear regression, ridge regression, and lasso regression, right? Let's take a gradient boosting regressor. Right. Again, you can ignore this warning. So if you see for gradient boosting regressor, it is 97%, 97.59, right? So it's along with KNN. So the KNN and gradient boosting regressor stands on the same pace. Now let's see for XG booster now. Let's run XG booster. So if you see for XG booster regressor, it is 98.69, right? So until this point, XG booster gave us the best accuracy. Now let's also see the random forest regressor also, right? Let's run it. Ignore this error. So out of all these models until now, we got 98% accurate models here. There are two models here, Dataset and XG booster. And XG booster, you see, for test accuracy also it is 98. So out of all these models, until now, XG booster is the best model, right? So it took very long time to run this random forest regressor, and it's worth the time because we got 99.72 accuracy. So random forest regressor gave me 99.72 accuracy, and the test accuracy is 98.09, right? So out of all these models, I would say XG booster and random forest regressor are the win, right? So out of all these models, I can say XG booster and random forest regressor both performed great. So it gave us more than 98% accuracy, right? And there is only one model left, that is support vector regressor, which gives us 86.18 accuracy, which is less than almost all of them. So we don't need to show it here because it's not worth of time. So I'm just showing you the best models out of them, and you see the XG booster and random forest regressor are the best models until now. And you can comment down below if you got any other models which are better performing other than these two. So let's see. So that's it for this diamond price prediction project. If you like this project, please share, and for such type of projects, please subscribe and watch till the end. Thank you. Thanks for watching.